Good morning, everyone. Hope you had already gone through the PPT which I had shared you regarding this topic itself. So today's discussion is regarding the third ionization technique in mass spectrometry, that is desorption ionization. This is the principle of desorption ionization. Please don't mind the language here because it's written in some other language, but we need the diagram. Okay. So the basic principle in this desorption ionization is there will be a matrix material and our sample material will be embedded in that matrix material, and we will be bombarding the matrix with the sample by using a high energy source. Okay, and when when it is bombarded, when the high energy source hits the matrix material which contains the analyte, which contains our sample material, what happens is it gets dissolved. Okay, the sample material gets dissolved from the matrix along with some matrix particles. Okay, and then it gets ionized eventually, and the ions are from there. It is a normal procedure, that is the ions are being sent to the analyzer and then it is recorded. Okay, there are three major types of desorption ionization techniques, and out of that, in your syllabus, we have to discuss about first two, that is FAB, fast atom bombardment, and Maldi, matrix assisted laser desorption ionization. Here, another one is here given, that is SIMS, that is secondary ion mass spectrometry. In all these three, the basic principle is the same, and the difference is the ion source or the high energy beam which we are using. In Maldi, we will be using lasers for high energy electron source, high energy source, and in FAB, these are fast atoms like xenon, argon, etc. Fast neutral atoms are used in the case of FAB, and when it comes to SIMS, the ions are cesium cations like cesium, etc. Okay, and when they hit the matrix along with the analyte substance, you can see that you can see here that these sky blue lines I have given, not I have taken from internet obviously, and this sky blue color spheres are the matrix materials, and the analyte is shown in the yellow figure, yellow circle, and these get dissolved along with the matrix materials. Not only the analyte but also the matrix material. Some of the matrix materials get dissolved, and eventually, and within that period, the analyte gets a positive charge. Actually, what happens is the matrix material is absorbing the high energy, and it is converting, the matrix is converting the analyte into its cations. Okay, now let's examine in detail FAB and Maldi. First one is the matrix assisted laser desorption ionization. Okay, Maldi. It's mainly used in the analysis of natural products such as proteins, carbohydrates, etc., lipids, etc. Okay, here the matrix, the sample for analysis is co-crystallized with the matrix material. Matrix will be very much large in excess. The ratio is normally 5000 is to 1. That is, for 5000 matrix molecules, only one analyte molecule will be present. Okay, that much in large excess, the matrix material will be present. Okay, when it is irradiated, what happens is, I'll show you the picture in the next slide. From there we will explain. This is the picture. You can see here that these green circles, are of matrix, and these yellow circles are of our analyte material. When laser beam gets bombarded with it, actually the matrix material absorbs the energy, and that matrix is converting our analyte into, that you can see here, the matrix material normally used in the case of Maldi is weak organic acids. Okay, normally cinnamic acid derivatives are being used, so it's very easy to protonate the samples material for the matrix, because matrix is a weak acid, it gives H plus easily. Normally these techniques are soft techniques because in the electron ionization or chemical ionization direct attack is there, but here in all these desorption ionization techniques the matrix is absorbing the energy and it is converting the sample into its cation, or it is imparting the positive charge to the analyte material. Okay, so they can transfer the H plus ions into the analyte material very much easily, and then these positive ions get converted into, or they are moving to another process, that the secondary process, that is for recording anode. Okay, and the matrix is, I told you, these are derivatives of weak organic acids. Normally cinnamic acid derivatives have been used. Here are the main example, here main compounds which are used for as matrix, that is alpha cyano for hydroxycinnamic acid, like the same cyanopenic acid, and then DHB. These three are the most commonly used matrix materials. And when you come to FAB, the difference is that instead of lasers we are using the high energy bombardment. Normally noble gases have been taken, are used. Argon and xenon are the common choices, okay, natural choices, and everything else is the same that we can depict here. Here fast particle beams are coming, and in this green spheres there are ions are given, and matrix ions are given in blue spheres, okay, and both are getting here. The difference in FAB is that all the matrix materials also are getting positive charge, and there will be a spectrum corresponding to the matrix material also, okay, but it won't cause a problem because we already know that what will be our matrix material, and corresponding to its molecular weight we will get a spectrum, okay, we will get a peak in mass spectrum, and that is easily avoided. It will not cause any confusions, okay. And when you move on, and here the same procedure, I told you the same procedure from there happens. It goes to analyzer chamber and then it gets recorded. And if you see the FAB matrix materials, normally these two are used, that is meta nitrobenzyl alcohol and glycerol. Okay, and the main difference between FAB and Maldi, we have talked about the similarities, okay, and the main difference is that their laser is there. Here we are using a continuous, not only ion beam, a continuous beam of atoms we are using. And with Maldi, the matrix is solid crystalline, okay, the nature of the matrix is solid crystalline, whereas in FAB it is a liquid matrix, okay, and Maldi is more sensitive than FAB, okay. FAB is 10,000 times less sensitive than Maldi. Means in sophisticated instruments we go for Maldi other than FAB. Hope the topic is clear. Okay, thank you.